Okay, everybody, today we're going to talk about transformation of functions. First of all, let us talk about some very basic functions that we start using them, and then we're going to see how we can transform their graphs using algebra and also online website. So the very first function that we talked about is, well, a linear function. All right, a linear function. A linear function was described as y equals to mx plus b. Remember that m was the slope and b was the y-intercept. For example, suppose we have a function y equals to 2x plus 1. The questions that you can ask is, well, what is the slope? The number that is multiplied by x is 2, so you have a positive slope. It means that the line is increasing. Well, you can find x-intercept, y-intercept of this line as well. To find x-intercept, we set y equal to 0 and then try to isolate our x. All right. So when y is equal to 0, you have 2x plus 1 equal to 0, or 2x equals to negative 1, for x is negative a half. You can also find the y-intercept. To find y-intercept, or the point of intersection with y-axis, we set x equal to 0 and try to isolate our y. So when x is equal to 0, the linear term becomes 0. Y becomes 2 times 0 plus 1, or y becomes 0 plus 1, or y becomes 1. X-intercept and your y-intercept. This is what we learned about a linear function. The second function that we talked about was a quadratic function. The second function that we talked was called quadratic functions. So, second function, quadratic function. Well, the general form for a quadratic function was y equals to ax squared plus bx plus c. Remember that we specify that a, the leading coefficient, is not 0. If it's 0, it means that this function becomes a linear function, which is not of our interest. We already talked about linear function. We want to work with a new function, which is called a quadratic function. So for a quadratic function, remember that the same as before, we said, hey, we can find x-intercept. To find x-intercept, we set y equal to 0 and solve ax squared plus bx plus c equal to 0. Well, remember that to solve this, we can either use factoring or using quadratic formula. quadratic formula? Well, quadratic formula says, well, x is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. For a quadratic function, you can find y-intercept. Well, to find y-intercept, we set x equal to 0 and y becomes c. Okay. One more thing we talked about quadratic functions was the axis of symmetry. The axis of symmetry, x is negative b divided by 2a. This is a vertical line where the parabola is symmetric with respect to that vertical line. So x equals to negative b over 2a. This is your axis of symmetry. So these are the general things that we learned about a quadratic function. And remember, they call the graph parabola. Now we're going to write one example about a quadratic function and start changing its x-axis, changing the y-axis, and see what's happening to the graph of the function itself. What transformation you're going to see. Okay, now let us write one example and then try to see what we can do with that example. So suppose I give you this example of a quadratic function. So suppose we have y equals to 2x squared plus 5x plus 1. Okay. First of all, I want to graph this function. Let's take a look at Desmos. See what do we have. Graphing calculator. I have 2x squared plus 5x plus 1. Well, this is the function graph. This is the parabola that we have here. We have x-intercepts, we have y-intercept, and here it gives you the vertical axis, axis of symmetry, negative 1.25. So x equals to negative 1.25 is the axis of symmetry. It means that the graph is symmetric with respect to this line. It means that if you fold the graph to the left, to the right, it's going to be symmetric with respect to this vertical line. Okay. Now, what I'm going to do, I'm going to make some changes to my x value. What do I mean by that? Take a look at this. I'm going to write it as 2 parentheses. Instead of x, I'm going to do a little bit of substitution. X minus 1, close parentheses, raised to the second power, plus 5 times x minus 1, close parentheses, plus 1. Ooh, what happened? Guys, my original graph was 2x squared plus 5x plus 1. I made changes to my x values. I shifted my x values and I see a shift, horizontal shift in the original graph. This is green graph is the same graph as the red graph. In the behavior, it opens up, right? But it shifted 1 unit to the right-hand side. So subtracting 1, make a horizontal shift to the right. Well, what if I change it to 2? I'm subtracting 2 from x. See what's happening. Wow, the graph is moving further away, more shift to the right. Subtracting 3. See what's happening. Guys, I'm just subtracting some numbers. Wow, it moved further away from the original graph. Subtracting 6 from x. Now you see this is on the right-hand side, just running away from your original graph to the right-hand side. So now I expect you to ask, what if instead of subtracting, we start adding? So suppose I added 1 to the graph, 1 to the x value. Hey, my graph is moving away to the left-hand side. What if I add 2 to my x value? Ooh, moving to the left-hand side. So adding numbers, make shift to the left-hand side. Subtracting, make shift, horizontal shift to the right-hand side. Adding to the left, subtracting to the right. So this is horizontal shift. So in general, you can say that for any function, y equals to f of x, we have the following case. F of x plus a positive number like c, make a horizontal shift to the left. Wow, it's going to the left. So adding c, horizontal shift to the left, and subtracting, make a horizontal shift to the right. Wow, okay, nice observation. If I add a positive number to my x value, it makes a horizontal shift to the left. My graph runs away to the left. But if I subtract a positive number from x, it makes a horizontal shift to the right-hand side. Well, so this is y equals to f of x. I only make changes to my x value. I expect you to ask, what if I add or subtract a number from my y? What observation do we have? Let us take a look at the graph. So what I'm going to do, I'm going to make some adjustments. So this is y equals to 2x squared plus 5x plus 1. This is my original function, right? Now I'm going to add 1 to my y. Y plus 1 equal to, we're just going to copy down this guy here. Okay, this is my original graph. I added 1 to my y value, and the graph drops 1 unit downward. What if I add 2? Ooh, it's going further down. Adding 3 to my y, going further away downwards. Well, What if I just subtract -2? It makes a vertical shift to my graph upward, all right? So in general, take a look at this and think about it this way. Remember, our y is isolated on one side, all right? When you're making changes to y, it means that you're making changes to this expression itself. It means that when you're adding 1 to y, it means that you're adding 1 to the whole expression here. So take a look at this. I'm adding 1, adding 2, adding 3, adding 4, adding 5, adding 6, adding 7 to the y value. My graph moves upward. If I subtract 1, subtract 2, subtract 3, subtract 4, subtract 5, subtract 6, my graph starts moving downward. So do not add or subtract to the y value on the left-hand side. Add and subtract to the expression on the right-hand side. So what is our observation then? F of x plus a number like k makes a vertical shift upward. Make a vertical shift upward. And f of x minus k make a vertical shift downward. So far, we saw these observations, these changes, these transformations to our function. Again, adding, subtracting to the x, horizontal shift. Adding, subtracting to the y, vertical shift. Now, suppose you have, I'm going to give you a nicer graph, easier graph to be drawn. Suppose you have y equals to x squared, okay? This is just a quadratic function. The graph opens up, the parabola opens up. What I'm going to do, I'm going to put a negative sign in front of my x squared. Ooh, what happened? So your y values here are all positive. Am I right? But if I put a negative sign in front of your y value, which is x squared, all y values become negative. The zeros stay the same. It doesn't change the sign of the zero. So when you multiply your function, the y value, by a negative sign, you have reflection with respect to x-axis. Your graph was up, it was open up, now it is opening down. So multiplying y value by a negative sign gives you reflection with respect to x-axis. Another example. Suppose we have square root of x. This is my square root function, square root of x. It doesn't take on negative value inside the radical because, for example, square root of -2 is error in your calculator. It's not a real number. The graph defines between 0 to positive infinity. This is the domain of your function. This is the graph. These are the y values. So now I'm going to multiply my y value by a negative sign. Square root of, ooh, take a look at this. Now I have reflection with respect to x-axis. My graph is reflected with respect to x-axis. All y values, they were all positive. Now I'm multiplying my y values by a negative sign. So of course they are now flipped, and we have reflection with respect to x-axis. So let us write this down. Negative f of x, negative f of x gives reflection, make a reflection with respect to x-axis. I multiply my y value by a negative sign, and I get a reflection with respect to x-axis. Now, what if I just multiply my x by a negative sign? Wow, take a look at this. Multiplying my x inside the radical by a negative sign gives me reflection with respect to y-axis. So if I multiply my x by a negative sign, I have a reflection with respect to y-axis. So multiplying the y value by negative sign gives you reflection with respect to x-axis. F of minus x make a reflection with respect to y-axis. Well, one important function is absolute value function. So let's talk about absolute value function.